All right, well, it's 2 o'clock, so we'll get started here. Thanks everyone for joining me today. Going over the care and feeding of your VFD, hosted by Winn-Marion. I got a couple people on the line with me. I've got Andy Kaiser, who's one of the regional sales engineers for ABB. He'll be filling me in on details that I miss. And I've also got Matt Robinson as well, who's the regional application engineer. So I've been working with these guys for combined about 11 years or so. So we were pretty dangerous in the world of variable frequency drives. So today, in case you forgot, is Wednesday, May 27th, 2020. I know every day can kind of be seem kind of similar these days. So just some housekeeping items for those of you that haven't navigated around yet. I'm going to be using chat. Everybody's muted, so if you do have any questions, feel free to throw that in the chat. That way I can answer the questions and or unmute you if needed. And like I said, this is being recorded, so we should have a copy of it later on. With that, I think I'm going to get started here. Just to take a quick check. I'm assuming everyone can hear me. If you guys can hit type in the chat that you can hear me. I just want to make sure. Anybody? All right. I see some feedback. Yep. Awesome. All right. So just a little bit about Winn-Marion, since they're paying the bills here. Winn-Marion founded in 1972, so we've been around for a while. We've got several offices kind of scattered throughout the Mountain West. You can kind of see our expansion on the timeline on the left-hand side there. We're about 200, 250 employees throughout the Mountain West. And our mission is to provide state-of-the-art automation solutions through superior sales, service, and innovation with an unmatched commitment to quality. And some of the things that we do controls, or industrial controls, skids, that type of thing. We've got some, HMI for a DCS on the lower left-hand corner. That was for a geothermal plant. Some of the other pictures you see here are on some gensets using a Woodward governor controller. We also do lots of PLC, lots of I/O. We do a fair amount of work in the oil and gas business, and we do a lot of work in the process automation business as well. And along with that, we do more specifically a lot of stuff with VFDs. So not only do we package VFDs, integrate them, we also have electricians on staff who are specialized with VFDs as well. So we can put the whole package together and then service it as well. So you can see a couple of our couple pictures from our work that we've done, and then also with the VFDs, we've also got some heat traces and lots of instrumentation as well. So we can do a fair amount of work in the industrial and process automation space. So with that, getting to the subject of our webinar, the care and feeding of your VFD. And first off, when you're getting a new VFD, you gotta figure out, where is it going to live. So the important thing you want to take into account is going to be the environment. So I've got a couple pictures of some varying degrees of environments. Kind of the upper left-hand corner there, kind of a VFD hanging out on the side. I think that VFD just tried to give itself up because it's given up all hope. That's why it's off the DIN rail. Usually not a great place for the VFD to live. Also, there's another picture with some sort of white frosting. Again, I don't think that's a great thing for the VFDs, at least not in my experience. I think the VFD is still working, judging by the LCD screen there, but generally not a good place. You also want to make sure that your VFDs can breathe. So placing bags over them, generally not a good idea. Generally they'll heat up and not work so well. And you also want to make sure that the VFDs are in a place where they're not going to have any extra roommates or anything. So when you pop open and see critters, generally a bad thing, both for the critter and the VFD, at least from a long-term perspective. Generally what we like to see is VFDs they're like any other electronic. Think of it like your computer. They like to be in cool, clean rooms. So I got that picture on the lower section there in an e-house we were at a couple months ago. Lots of drives, lots of space. That building had its own air conditioner, so great in the summertime. Keep the place cool, keep the VFDs cool, give them a nice long life. Another picture there we've got, it was a mobile unit for a test stand. That unit's actually going to go outside. So we have what's called a NEMA 3R rated. So it can be outside, take a little bit of rain, but not a hose necessarily, and keep the drive dry outside of the elements. So just to give you an example of some of the various enclosures you might run across from manufacturers, ABB's got a couple of them. We've got on the left-hand side there, we've got what's called the NEMA 12 offering. That's great for dusty conditions. So oftentimes a lot of manufacturing sites, process plants, we may do a NEMA 12 type enclosure just to kind of keep dust out, but it's not good for rain or moisture. That's still going to be able to get in there. And then on the top row there, I've got a couple of them. Starting all the way over on the right with the ACS 880, kind of the top of the line one, comes in 2 flavors. It's a NEMA 12 as well as a NEMA 1. NEMA 1 is what you're going to commonly see hanging on the side of a wall. So, any place you wouldn't put your laptop or any other electronic device, you would not put a NEMA 1. NEMA 1 is basically just to kind of keep out fingers, hopefully other critters, screwdrivers, things like that. If you bump up against it on the side of a wall, that would be a NEMA 1. We got the ACS 380. It's more of a machinery drive. Again, typically you're going to put that into a cabinet, kind of like in the pictures I had previously. So that will generally only come in NEMA 1 because it's typically going to be installed with a lot of other drives next to it. Then we've got the ACS 580. It's more of a general purpose drive. Again, we've got a NEMA 1 and a NEMA 12. Usually that's kind of a 50-50 mix between being installed on a wall versus being in a cabinet. And then I've got another line called the ACS 255. That one pictured there, that's actually a NEMA 4X. The NEMA 4X is going to be good for more a lot of food and beverage type applications. So there's going to be what's called a washdown. So that can actually take a hose to it. So it can be outside in the rain, take a hose to it. Direct sunlight is another issue, generally because those LCD screens tend to wear away. But generally, they can go outside in some pretty rugged conditions. And then while we're looking at all the other drives, ABB does make a DC drive as well. That's located next to the ACS 255. So for any older applications, DC drives are still out there. And so when you're getting your new VFD, when you want to make sure it's got a nice place to live, but who is it going to get along with in terms of its other components it's going to be interacting with. So motor type, that's really important. You want to make sure that the motor type, you have the right insulation on it. Generally, most motors that you're going to buy today are going to have a F-class insulation or an H-class. H-class is typically referred to as kind of an inverter duty type insulation. It's just got a higher temperature rating. So when a VFD is controlling a motor to go slower, generally some heat can build up in the motor. So you want a higher insulation. So you want to make sure it's at least F or better. There are some older applications that I come across from time to time that may use a B type insulation. That's an older motor. Yes, you can put a VFD onto a motor with a class B insulation. You're just likely going to fail the motor a lot faster than you normally would because that insulation will basically heat up, wear away, and then cause a short. Taking out the motor, possibly the VFD. And then not all VFDs are going to get along with all motors. So I've got 3 different motor types here. We've got typical AC induction motor. I've also got a servo motor, permanent magnet servo motor. Generally, when you're using servo motors, those are going to be higher performance applications. Sorry, I've got a question here. Turn down ratio. Turn down ratio would be when you are slowing the motor down. So motors are going to have a typical base speed. Common motor is 1800 RPM. The turn down ratio, if you have, say, a 10-to-1 turn down ratio, basically going to turn that motor down from 1800 down to 180 RPM. Just move the decimal point over. And it's when you're slowing that motor down that that fan on the back end that's fixed doesn't go as fast. So that's where you're going to be going, having the motor heat up. Sorry, where is it getting back to? Servo motors. Permanent magnet servo motors, generally higher performance applications. Not all drives are going to work well with permanent magnet servo motors. So you want to make sure that your VFD will actually get along with it, and you're not needing to get an upgrade or whatnot. And the bottom one is actually a newer motor technology called a synchronous reluctance. Synchronous reluctance, you're going to see these in a lot of fan applications. Generally, their efficiencies are about equivalent to what a permanent magnet motor might be, and roughly 20% on average more efficient than, say, your typical AC induction motor. So again, because it's a newer motor technology, not all VFDs are going to be able to handle that. So that's on the motor side. On the other side, you're going to have the electrical network. This can be an issue, and it can be an expensive issue too, with the grounding network that you're working with. Oftentimes out west, I see what's called a corner grounded delta, and that can have really bad effects onto a VFD. Some VFDs will have what's called an EMF filter, just basically filter out some noise that's going to happen, going to occur on the electrical lines. So a lot of VFDs will have an EMF filter to basically turn that down and get rid of that. Unfortunately, that EMF filter also goes directly to ground as well on the VFD. And so if you have that filter turned on and you have the wrong type of grounding network, you can actually blow up the VFD pretty much on start. You'll know right away if you're wrong. And so depending upon the horsepower of your VFD, that can be a relatively expensive mistake. Also, other factors to consider might be power factor correction capacitors. Generally, we've seen smaller VFDs, somewhere in the neighborhood of 5-10 horsepower. If there is a power factor correction capacitor on the same electrical network, that can often eat away at the capacitors on some of these smaller VFDs and eventually killing them as well. So just be aware of the electrical network. Make sure the motor type you're working with, they're all going to be compatible with your VFD, so they can all kind of get along. And also, now that you've got the VFD, you figured out the VFD you want to use, now you're going to get it installed. So what to inspect when you're inspecting. So you're generally going to have 3 time frames you're going to be looking at. One is going to be startup. So when you get the VFD already, you're gonna power it up. You're actually gonna get it to start turning the motor shaft. You want to check the voltage. Make sure, as a final check, make sure that the voltage that you think is being applied to the VFD is compatible. You want to make sure that you're not putting 480 volts where maybe a 230 volt should be. That can be a bad thing. You want to also make sure that your wiring is using the proper wiring. Is the gauge of the wire appropriate for the amp that you're going to be doing it? Just because a electrician wired it up doesn't mean it's always correct. So it's like double check. Grounding as well. There was another expensive mistake I learned of a couple of months ago where an electrician had actually put the grounding onto the DC bus. And Roman, you want to chime in and see what's going on here? Actually, I can't unmute you, Roman. Sorry. Is that you, Roman?
Hello?
Is that you now? Hey, there you go.
Can you hear me?
Yep, you're on now.
Okay. So I like that picture to the left that you have there. I was up at Snowmass, and unfortunately we didn't start these drives up. I was there because of the explosion that happened. So there's 4 big 600 horsepower ABB ACS 880 drives, and as I pulled this drive out to inspect what went wrong, that picture right there, I saw a bunch of knockouts from the VFD installation from the electricians, and a lot of fender washers inside. And it wasn't just this one, it was in all 4 of them. So it happens, and that's something that, as a startup guy, that's something that we inspect before we turn that power on, because once you turn that power on, it's all over. You can't go back. In the case that Mike said, yeah, some other electricians also put the ground wire on the DC bus, which obviously, as you know, that will blow up a drive instantly. And then not only once, but they did it 3 times. So inspection on startup is very important, as well as observing grounding to make sure the grounding's correct.
Yeah, and I believe he did it 3 times. So that was a total of about $100,000. So that's a really fun weekend in Vegas, I got to say. And then swarf, swarf's a fun word. It's in the dictionary. I love it. But that's basically what Roman was talking about on the lower left-hand side. All the washers, once they start to cross a DC bus, bad things can happen, as denoted by my little friend right next to my swarf picture. Apparently he was having a really bad day, and he crossed the streams, and didn't end up too good for him. So that's just startup. Periodically, you want to check fans, filters. Again, I always like to mention people talking about grounding. When you're seeing grounding, we work on ski lifts a lot, and grounding in the summer is typically different than what it is in the wintertime. And so sometimes it may be a little bit higher given the time of year and the network. Sometimes, based upon stuff that's going on in the factory, the grounding may actually get cut, and nobody knows about it until VFDs start failing. So if you're checking grounding periodically, once a quarter or annually, at least lets you know if something's amiss. And then annually, I've got also down there, bolts, picture on the right-hand side there. I've got some marks, so you can see if there's vibration or thermal expansions or whatnot. You can see if those bolts are coming unloose. Again, grounding, and then also check on spare parts as well. Oftentimes, VFDs run into issues because they have capacitors on them. Those capacitors actually dry out essentially, and so if you have VFDs that have been sitting on the shelf for more than a year, you may have issues when you actually start them up again. And I can talk about that later.
On that point too, Mike, I will tell you that most customers are reactive rather than proactive. And if we can, when we sell a VFD to them, depending on the size of the VFD, we probably should pitch spare parts. Case in point, NGL Midstream up in Greeley, they bought a spare part package. It was like $18,000 worth of spare parts. And not only after about 6 months of buying that spare parts, they had a grounding issue that no one knew, and it blew that drive up. And me and Josh were in Fort Morgan repairing another drive at Western Sugar, and we got the call. And because they had spare parts, we were able to get there and get that drive up and running within 3 hours. So not a lot of customers will buy spare parts, but when they do, it's very useful.
Yep. So a lot of it comes down to uptime and the critical processes, and then also generally we like to preach about having the proper type of wiring for VFDs as well. A lot of people tend to use what's called THHN wire, which is the typical wire you're going to get at your local hardware store. It's just basically got a kind of a thermoplastic around the copper. The better option to use is actually VFD cable, which is going to have its own shielding on it. We can actually also use, I have seen THHN if it's in its own conduit as well. I have a whole another topic on proper wiring and whatnot, but having the proper wiring is another place to set yourself up for success, and something I would do when you're actually installing the VFD and working with your VFD people and integrators and whatnot. So in general, oops, there we go. Inspection and maintenance. Again, most manuals should kind of cover a lot of the things that I just talked about in terms of replacing. You're going to have a periodically check. You're going to have inspecting. The critical kind of life periods, life periods for a drive are going to be somewhere around 3 years, 6 years, 9 years. You can kind of see this is from it's actually from an ACS 880. Where after 6 years, it looks like they're wanting you to look at some of the batteries, the real-time clock batteries on the control panels. Obviously, you're checking filters and fans, making sure the filters are clean, the fans are still running, and then about 9 years, you're probably going to want to replace the fans to make sure that those are still running. They're typically not built as robust as the rest of the VFD. And so replacing the fans, they just won't have as long a life. And then also generally around somewhere around 9 years or so, you may want to be replacing the DC capacitors, the DC bus capacitors as well. Those are items that eventually will wear out. Because if you're good, you keep the VFD cool, clean, happy. I mean, I've seen VFDs that are 20 plus and approaching 30 years old if they're kept in the right conditions. So it is possible. It's just a matter of like I say, how proactive you are. And so kind of gets us to the next slide is going to be life cycle management. All products, whether we like to hear it or not, eventually they will basically get sunset. They will no longer be made, and so you have decisions to make at that time. Do you upgrade? Depending upon the drive, sometimes you can kind of rip the guts out and replace it with kind of the current model, maybe an upgrade kit, so to speak. You can also obviously repair it when it gets to a certain time frame, and then you can also replace it too. Generally for customers, depending upon how many drives they have, it may be some combination of all of them. I know there's one customer we're currently working with. They've got 4 of the same drive, and they are, I believe, about 400 horsepower. The drive they have is basically going to be discontinued in the next couple of months. And so what we're going to do is we're going to give them the new 880 drive, and then they're now going to have a drive, an extra drive they can effectively use spare parts for the other 3 drives, and so they can rotate those drives out. And so again, just things to think about. When you're getting a new drive, you want to make sure that's not going to be phased out anytime soon. But then 5, 10, 15 years into the drive's lifespan, you want to figure out do you want to try and take advantage of some of the new functionality? Do you want to take advantage of some of the other maybe some rebates that might be out there? Maybe there's you need to put more stuff into the same room, so maybe the new drive you have might be a little bit smaller, things like that. But when you are doing this, you want to make sure you've got a backup of what the VFD has on it in terms of the program, because obviously you're going to need to convert that over at some point. If you're going to be replacing the drive, you want to make sure that if there's a PLC involved, that you've got your PLC automation person aware of it, because oftentimes it's not as simple as just pulling one VFD off the wall and putting a new VFD on there. There may be some VFD code, or sorry, PLC code that we need to replace. And along those same lines, ABB, for example, has what's called adaptive programming. So we can actually I call it PLC Lite. So we can take some of that PLC functionality and actually put it onto the drive. So maybe there isn't need for a PLC anymore on that new one. And then, yeah, you might want to also work with, when you're getting new VFD, your power provider. I know at least in the Denver area, both United Power and Xcel Energy have rebates, so that when you are getting a new VFD, oftentimes there'll be a rebate that's involved as well. And then, so that when you do actually replace it, hopefully you're not having to deal with anything like this. I'm pretty sure that the panel on the right-hand side, the schematic is on the left-hand side, so it's probably up to date. Usually never is, and everyone knows where everything is. So we know where the backups are, where the schematic is up to date. So all these other fun things you get to best to deal with as a best practice when you are replacing a drive or upgrading a drive. You want to just it's a good time to check and make sure that you've got everything backed up, so you can have a much better experience when bad things happen. All right. So kind of going along there, getting near the end of the presentation here, kind of recapping some of the stuff Winn-Marion can help everyone out with their VFDs. As Roman mentioned, we can do startup, make sure that everything is as correct as we can get it. There can be extra swarf. There's your grounding is good. That when we turn the power on, we won't let the magic smoke out. Capacitor reforming. So I mentioned before that VFDs that have been sitting on the shelf for over a year or so, the capacitors on them will tend to dry out, and that's not just with ABB VFDs. This is pretty much any VFD out there. They'll dry out, and what we end up having to do is effectively reform the capacitors. Basically, we'll put voltage onto the capacitors and wet them essentially, so they're not dry. And that way, when we do actually put current through them, the capacitors remain intact and do not let the magic smoke out. So they'll work that way. System integration. So we saw a fair amount of the pictures. We can do PLCs, DCS, obviously VFDs. Integrate that all into one package for customers. And along the same lines, troubleshooting. So when you are chasing down electrical gremlins, we can go and understand where that's coming from, offer a solution, and get you going down the road. Along similar lines, package a solution that touches along the system integration. And then DC drives, I touched on that before, but DC drives are still out there. We run into them a lot in a lot of the older industries. I know I've done them a lot in plastic extrusion and ski lifts still. And then the other one I like to talk about is drive surveys. And drive surveys, this is really a nice thing to do, because we can go and inventory all the VFDs you've got on site. And kind of give you a snapshot of what your facility is dealing with. So, is there a preventative maintenance kit that might be due? If it drives, like I said, 10 plus years old, maybe you want us to look at it and make sure that we've got fans, filters, capacitors, that type of thing. That way, we can give you another 10 plus years on your drive. Lifecycle management is where we talk, about, okay, if your VFD is no longer available, how do you want to handle what happens when the VFD goes down? Is that going to be a straight up repair? Do you have a backup? Do we want to upgrade? Just to kind of give you an idea as to what's going on, keep your facility up and running. Because obviously, uptime is what we're talking about here, especially nowadays. Uptime, generally don't want to buy new if you don't have to. You want to keep what you have running longer. So just got a couple pictures of some of the things that we do. So there's one panel. This is a NEMA 4X panel. We've got the AC on the left-hand side there. That's actually a module unit there. So basically all the busy end of the drive is on the right-hand side there. And then there would be a control panel mounted on the front to program the drive. And then we've also got another one, again, more VFDs and electronic gear that we've done and rolled through our shop in Centennial. Also, there are larger packages as well. Ones on this picture, mostly NEMA 3R. These are ones that we can do pretty quickly within a matter of weeks between control panels on the door, push buttons, disconnects, whatnot. There's also a drawing of some of the larger units that we've done. Multiple drives, lots of inputs and outputs, measurement, instrumentation, that type of thing. So about 2:32, I'll just pause it there. Are there any questions that anyone has? Okay. Well, then I will. I'll start to wrap it up here. So just some of the customers, or sorry, some of the vendors that we work with at Winn-Marion. ABB. We're obviously heavily partnered with VFD, one of their value providers in the U.S. Got Thermon for heat trace, Woodward for a lot of generator controls, and a bunch of other valves and controls that we use, and we tend to integrate them into our packages. And then some of the customers that we've worked with in the past as well. Some of these names might be familiar. Micro Technologies, they're a food and bev company out in the Aurora area or so. We did a rather large process integration for them that was north of about $1 million, and I think somewhere in the neighborhood of 10,000 points of I/O. But they basically do they make protein powders that are in a lot of the packaged food these days. Tersa Solutions, they actually do a carbon dioxide-based dry cleaning device. Military police actually use these machines a lot because it's really hard to wash bulletproof vests, whereas they actually use CO2 in a high pressure situation to actually wash them. Obviously, in our oil and gas, we've got ExxonMobil and Hess, again, doing a lot of some of the refining there with a lot of our process instrumentation. We've got Kinja from the Colorado herbs that we grow here. Again, that was another CO2 extraction process. Metro State, we actually did a bunch of demos, PLC learning demos for them. That way, kids going through school can actually get hands-on with some of the ABB PLCs and whatnot. So we've got customer testimonials, and then lastly, if there are any questions that anyone has, feel free to follow up with me, Mike Savoie, or Helen King. You may have also received an invite from her for this. But thank you for attending. Unless there's any other questions that pop up, I am probably going to end the presentation. So I promised an hour. I got 35 done in 35 minutes. Yeah, and like I said, everyone should be getting if you signed up, should be able to get a recording of this. And any other questions, feel free to follow up. And I am going to sign off. So thank you very much.